Recording in progress.
Hello everyone, and do you hear me? Before we start the lesson, please make sure that you can open the camera and let me know you're here. The double lesson today. Now I recall your memory on our task. Last time on here, so you are asked to think of the class practice, the question 2. Okay, this is the one, and this is the core part of the previous lesson. All right, do you find it? 24, page 24. Okay, question 2. Solution of which alkali must be used to distinguish? You take a look at the word distinguish, 分別. So which means that you are going to use one alkaline and you can easily know which is which, okay? In case the solution containing zinc ion, the other solution contains lead-2 ion. Both solutions, they are colorless originally. So it's quite hard to distinguish based on their own observation. You need to do a test by adding an alkali. So what is that alkaline and what's the observation? You know the questions, okay? So as said before, for the students who come, could you please open the camera? Chen Jiaming, Hin. Can I have Chen Jiaming to tell me your understanding about question 2? What do you think? What alkaline can be added to help you distinguish? The solution is zinc ions or the solution is lead-2 ion?
Add a few drops of dilute aluminium.
What is that? Sorry, a few drops of aluminium. So what does mean by aluminium? You mean ammonia solution?
Yeah.
Is it ammonia solution? Your symbol? Can you tell me the chemical formula?
NH3.
NH3. We call that ammonia. Okay, ammonia. So if you tell it is aluminium, is another thing.
Okay.
So aluminium is this, okay? It's not the same.
Oh,
And if you say that alumina, you talk about the third thing. It is Al2O3, a common name of aluminum oxide. But you say that alumina, I don't know what's that. So remember, those be aware of the pronunciation of each word because a slight difference, it will give you a different meaning. Okay, so this time we are going to use alkaline ammonia, aqueous ammonia, ammonia solution. It will help you distinguish. Okay, so what is the expected observation? Yeah, as Mr. Chen, you may continue. Yes.
如果有呢個 zinc iron 嘅話，就會係個 PPT 會 dissolve to give a colorless solution。如果係有 lead to iron 嘅話，就the PPT will not dissolve。
Okay, when alkaline added, it is in a few drops or in excess? A few drops or in excess. So this is a very important question. Little amount of ammonia added or excess amount of ammonia added, the observation is different. So Mr. Chen, could you please say it again?
When a few drops of ammonia add to the solution contain zinc iron, the PPT will dissolve to give a colorless solution.
So you just say that again. Now, be aware of what you have just said. You mentioned a few drops only, but later on the second statement, you tell me the PPT dissolve.
Oh.
Okay, so it's different, right? When it is not when the ammonia added is just a little bit, but you are going to add it in excess. So we have got both stage. First stage should be a few drops of ammonia solution added. Both solution give white PPT. Okay. However, while you add the ammonia solution in excess, okay, the solution with the white PPT, or you just said the precipitate. Remember, this full term, you need to write down the full name. With precipitate dissolves in excess alkali. Is what?
Solution containing zinc iron.
Yep, it's the solution containing zinc iron. Okay, while the other observation, the solution with the PPT remains. Okay, which means that the solution, the PPT will not be dissolved, remain undissolved. So you want to make it more clear explanation, you write down undissolved. Is the solution where containing lead 2 ions. Okay, is that clear? So this is but both they will form by PPT, but the 2 PPT is different. For the solution containing zinc iron, the white PPT is in the form zinc hydroxide, while for the lead 2 ions, the PPT is still white, but we'll call that lead 2 hydroxide. While if I add ammonia solution in excess, okay, so it dissolve in excess alkaline. What is mean by that? It form a colorless solution. While colorless solution, we have got a colorless complex. So the answer is tetramine zinc. So this is the ions which responsible, complex ion responsible for to tell the solution being colorless, okay? However, we will not see this in Lab 2, no such. Okay, is that clear? So this is what I would like to remind all of you. Please take note of that. Now it's time to have a practice of writing those sentences. Okay, you better take out the notebook and then try to write once or type it once. Okay, instead of capturing a photo, right? Maybe capturing photo, you do not have any deeper learning. Now you better write it and practice it. Any questions? Any questions? So the word distinguish. Okay, the word distinguish means that the test will help you make the difference, right? So remember, if you want to know which is which means that the observation will be different. So you are looking for a test in which the observation is different. For the first one, it's not enough. Okay, for the first statement, which means that if I have an aqueous ammonia solution, I just add a few drops. Okay, the observation, they are just the same. So you cannot still get to know which is zinc ion, which is electro ion. Only when ammonia solution is added will you start to know that from the here comes different observation. One of the PPT will dissolve in excess alkaline, one of them will not, and I will know which is which. Do you understand? Do you understand? So be careful of the word. That's why I need you guys to be highly aware of the wording. Now, I just circle it. If you don't mention the ammonia solution added with the lithium amount or in excess, even though you write down the observation, I will not give you marks because you did not tell it very clearly. Under what situation will the PPT be performed, or under what situation will the PPT will start to this to do you understand? You got it? You got it? Okay. Matthew, you are late.
Yeah.
12.
Yes.
Overslept? Seems not, right? From appearance, it seems not.
Yeah, I gone to the wrong class.
歐軒don't laugh so loudly. Oh, that's why in the fourth lesson you just intended to enter the Chem our Chem class. I read it from the notification. I know that you want to enter my class at fourth lesson. Anyway, Matthew, we just come to question 2. Could you please take a quick look, take a glimpse on it, take a picture on it? All right. Okay, so this is what the questions about the distinguish. Any questions? Now we will have that practice in the coming lesson as well. Okay, so we stop at this part. Any questions? Any questions so far? Now, if not, we come to the other. What is the point of telling you so much about this? It's because of the term identifying the INC unknown compound. Indeed, it is a basics of qualitative analysis. All of you, please mark it down. Qualitative analysis. Okay, qualitative 定性分析. So in chemistry, we love to ask for qualitative analysis and quantitative analysis. Okay, for example, in the just yesterday, Consumer Council has released a report about the food safety. Do you know what's that? Yang Zhongyin, tell me what do you know about the Consumer Council report yesterday? Talk about something. What is that? Food. A hint, food.
Food.
What food? You don't know? Anyone who know?
Rice.
Yes, rice noodles. Rice noodles, they talk about some of the chemicals containing inside the rice noodles, which is quite different from stated in the food label. For example, the sodium content is too high. You know that even though you talk about rice noodle, udon, all those, they are just full of sodium chloride. Don't you know that? It's because I add some salt into that to make you as to give you flavor to it. But it's not that terrible. It's because it's not a mismatch with the food label, but also some more nasty additives, especially some toxic additives added to those rice noodles before they sell, but they're not stated. You know what? So you better check the Consumer Council report. I give you one chance. You go to the web and search for that Consumer Council report or the news and send it to the chat box and let everyone know what I've just mentioned. Do it now. Now, so inside that, from the report, you may see that two items, which is quantitative and qualitative analysis. Quantitative means what? Means how many, how much content it is. But what is meant by content? The content, I need to know what is that inside. So you need to know what it is. Okay, so you want to talk about the chemical identity of that substance. I need to know what is really inside. So which means that if I take a look at the rice noodle as an example, the final statement, the conclusion is that it says that it has full of sodium. If sodium content, so we need to trace back to get to know what is the sodium content is. It can be what? It can be salt, table salt, sodium chloride, or it can be soda powder, baking soda powder, because the soda powder inside also contains sodium. So we will. That's why people will dig into detail and try to get the sample of a rice noodles to chop it into small pieces. I dissolve the chemicals out and do the testing to get to know what that is, first of all, and try to do their own analysis to get to know how much content. Okay, we are looking for and put it here. Okay, can you get my point? So this is the core part of a chemistry syllabus. Of course, if you're given a chance of doing experiment now, you need to do both. You need to get to know which is which, and how much content does it have. Of course, In Form 3, for first few syllabus, you have heard of some of the qualitative analysis. Could you give me some examples, Chen Yu? Have you learned something about qualitative analysis in Form 2, Form 3, Form 4? Chen Yu. Some example.
Some example, maybe.
For example, I give you a colorless gas tube of the gas. Let me know inside it is just pure oxygen. So what should you
Just
do?
use a burning spleen, glowing spleens.
Okay, so it is glowing spleen. So indeed, glowing spleen test is the test. It is a qualitative analysis. Okay, you get my point.
Okay.
Because that result is rather unique. Okay, the result is rather unique, and you know that only oxygen gas can relight a glowing spleen. So, whenever I use glowing spleen and the unknown gas gives relights a glowing spleen, I know the gas being oxygen. So the whole logic will be this. So this is what we call it as qualitative analysis. There will be something more about metal ion. What do you do? What do you do about metal ion? So besides having this, okay, besides having that flow chart, suppose you want to get to know the unknown metal parts inside the salt, you may usually use what? Flame test. Can you see the word flame test? However, flame test is not a universal test, which means that they cannot test all metal ions. In Form 3 syllabus, what you just know is about the 4 ions: potassium, sodium, calcium. What else? The 4th one is
sodium ion.
寫咗啦。
Oh, sorry.
死啦，真係唔記得咗。嗱，你預咗啦。嗱，for the others, be prepared of being asked。真得啦。
I forgot, but I forgot it.
咩啊？點啊？下個玩咗路啊 pass。
Kappa.
Kappa 2 ion. The flame color. You know my next question. 司徒宏軒。
Bluish green.
Bluish green for Kappa 2. Okay. How about the other 3? 曾浩正。
other 3 啊，potassium 就係呢類 flame 啦，跟住 sodium 就係 golden yellow。
Yep. Golden
red.
And yes, brick red for calcium. So this is what you know in Form 3 syllabus, but that flame test cannot test for the presence of other ions, just like magnesium ion. Now remember, very strange. Okay, magnesium ion doesn't show characteristic flame color, but magnesium metal can. Magnesium metal, I burn it, and give you a bright white light. So that white light is a very characteristic observation. Okay, but remember, for magnesium ion, it does not. So that's why you need to think of other tests. So adding alkaline, it is also another choice. Now, for example, if I add sodium hydroxide as example, do they form the precipitate? The answer is yes or no. In here comes the answer. But of course, if you say this one as example, you may see a very special term. It's a white PPT form. If yes, all those are just white PPT on the left-hand side. But if you say it is no, it can refer to something else. Can you see that? This one is problematic. What is mean by no white PPT form? Do you mean that white PPT will be formed, but it's not white, or indeed there is no PPT form? Can you get the logic? Do you know the difference? What is mean by no? No, which means that white PPT is formed, but it is not white. Now, according to the book, right, this is his logic. But to our understanding, if is a white PPT form, the question itself is problematic. If I want to say so, you want to change the wording a little bit. How? Matthew, how we change a little bit the English a little bit such that it matches with this? It's rather ambiguous to say so, right?
A different colored precipitate is formed.
But you say yes or no. So how
Yes.
you change the question a little bit such that you can say yes or no and we can understand which is which. How about this? Is the precipitate form white? Can you get my point? Is the precipitate formed white? Do you know the difference between these two sentences? Two questions. Now this one is rather ambiguous. Is the PPT form white? The hidden message is what? If I add NaOH into all those samples, all will form a precipitate. Some of them is white, some of them is not, such that we can do a splitting. Can you get my point? But of course, if you write down if you have this sample, you may think of another case, just like is a PPT form. Okay, if yes, you need to think of this question. Can you get my point? If no, what is that ion? Can you get the logic? By doing so, you can only use this diagram to help you devise the whole flow, the whole schematic flow of which is which. Do you understand what I've just said? You understand? Do you understand what I've just said? Do you understand?
And understand a bit.
Understand better. Just let me know what you understand.
I understand that when no white PPT is formed, it can be other color, but I don't know whether it can be colorless.
Okay. Now, indeed, we go back to the case on the unknown sample. It will include group 1 ions, ammonium ions, some other, right? So if you take a look on these, they are not comprehensive, okay? They does not cover them all. So if you barely use this map, they will give you something strange conclusion. For example, how about potassium ion, sodium ion? Can you use this diagram for help? No. No. Why not? Because for the first sentence, for the questions, it is already problematic. The first question it asks for is the precipitate form white. So what is the hidden message? The hidden message is when whatever chemicals it is, when I add dilute NaOH, the PPT must form. Is it universally true? Do you understand? So what is that exception? Now here, if I add alkaline to it, if you show that, do you have a chance of no PPT?唔知我問乜？ Anyone who understand what I've just said?
佢 dissolve 咗咪冇咯？
咁咩叫佢 dissolve 即叫冇啊 ？So what does it mean by that?
最尾個 product 係 aqueous solution。
So what is the hidden message? What is the hidden message? The chemical after mixing is water soluble. Do you understand? So give me the answer for that. And one more point, because I add excess to it, okay, so you better add a few drops on top. So the first statement should be is the PPT form. They were having that two arrow, one is yes, one is no. If yes, you go to the diagram underneath. If no, you directly go to the possible choice. Do you understand? So what is the PPT form? If the answer is no, if no PPT is formed, which means that all those chemicals they are water soluble. Any examples of metal ion? It will show you this.
Potassium.
Potassium ion. Potassium ion, good. What else?
Maybe ammonia. Sodium.
Sodium ion, yes, that's right. So it can be some other group 1 ion. There will be some other group 1 ion, it will give you this. Do you understand? 知唔知我哋講咩? So if you use adding an alkali as a first step of doing experiment, there must be two ways to think. One is that the PPT form or not form, okay, or no PPT. Only by having this, you make the whole chart more comprehensive. Do you understand? Now, never relying on each map because different people will have different philosophy of this map. I'll go to me, Mr. Chin. What I've just showed you is the different cases, okay, in which you may see in DSE. So that's why I add calcium and potassium as well. Now, of course, the map can be changed. This time is NaOH. How about NH3? If I change it to NH3, the whole flow here will be changed accordingly. Okay, you get my point. There will be another version. So you better make this chart as another chart for ammonia. Okay, such that you can get the similar flow. Do you understand? How about this carbonate? So in form 3, you may know that you tested carbonic ion. I use dilute acid as a case and to form colorless gas bubbles. Remember to test for the colorless gas bubbles by bubbling the gas into lime water in case it turns lime water from colorless to milky. Okay, so you know the gas is carbon dioxide. You can trace back the ion, it is carbonic ion. Of course, Mr. Chin, I have got some flaws in this. I can think of another example, another ion in which it will react with dilute acid to form carbon dioxide. What is another case? The one you appear in the book in this chapter. Anyone who can help? Besides carbonate, there are one more different type of ion which will cause effervescence when I add dilute acid to it. Anyone who know? Đồng Mã Hiên, you know? Đồng Mã Hiên,
No, I'm sorry.
you don't know.
Yes, I don't know.
You have seen it before. What you need to do is to turn to the previous pages. Find for the case in which we react with acid, they will form CO2. Go way backward, please. All of you, please do it now. Search for me. Before page.
第七頁
Yes.
calcium carbonate.
My question is, carbonate can react with acid to form CO2. Okay. I have got another ion. Can also give the same results. Can you give
Hydrogen carbonate.
Hydrogen
It
carbonate.
is hydrogen carbonate. Do you find my English so difficult to comprehend or what? You don't understand. So hydrogen carbonate and carbonate, they will also give you the same results. Can you see it? So what is the hidden message? If you got the white salt, if you got the solid, I add dilute acid to it, it gives effervescence. I test the gas, while it will turn lime water milky. Can we say for sure that it is metal carbonate? The answer is no. You can only say that it can be metal carbonate or metal hydrogen carbonate. Can you get my point? We have got two cases. Do you understand? 麥建陽，
理解。
Please use Cantonese to tell it once. Is it something about logic?
即係嗰個 hydrogen carbonate react with metal carbonate 會有 same result 同嗰個後邊嗰個嘢一樣嘅 result 咯。
So what is the conclusion? Is this test a unique test? Is this test a unique test?
Yes.
Unique? Do
I
you know the
think no,
do you know the
because
test unique? Yeah.
I think no, because there is 2 ions that can have the results.
Yes. Correct. Does the other understand what I've just said? It is not a unique test. It's because that, or if you in case it gives you a positive results, you can only use this to narrow down all other possibility into 2. But you still need to do further tests to get to know it is carbonate, not hydrogen carbonate, or is hydrogen carbonate, but not carbonate. Do you understand? So that's why we call it qualitative analysis. Just imagine you are a detective, 偵探. If you go to the scene, you don't know what is happening. You get the sample and you do the test and you give you the result like this. What is your conclusion? Can you get my point? We are doing something like this. So in case I've got that liquid sample, I take it and I add acid to it, it will give you colorless gas bubbles. Can we say that it is a carbonate for sure? Or can we say it's hydrogen carbonate for sure? Can you get my point? I can only say it is carbonate or hydrogen carbonate, but not I can say for sure it must be carbonate only, or it must be hydrogen carbonate only. Do you understand? For those who really understand what's just said, could you please put a tick? If not, across, please. Let me know if I would like to further elaborate. You understand? Well, at least you need to give me some positive response. Otherwise, I cannot continue. Now, my next question is, how can we further know? Okay, how can we further know it must be carbonate or it must be hydrogen carbonate? Can you get my point? How can I know that the sample, it must be carbonate or it must be hydrogen carbonate? How? Yes, that's right. Please look at Chen Yu. He started to open the book and try to search. Yes. How about the others? You may also do so by typing on the web. Okay, your internet game just started. You search the web and try to search for the answer. Do it now. I'll give you 1 minute and try to search the web. How can you distinguish between carbonate ions and hydrogen carbonate ions? Okay, 30 seconds left. Okay. Anyone who will help? How would you further confirm it is carbonic or hydrogen carbonic? Of course, I need to do another test. Only this test is not enough. So what is the hidden message? I do this is the first test, and then I do the second test. A series of tests. One first and then two. What is the second test?
Is it attain aqueous ammonia?
Aqueous ammonia. So what is the expected observation?
The ammonium ion is given out.
Oh, in which case?
Which I think is no, I find it online in the web, and it could be distinguished by ammonia by the it give out ammonium salt.
Ammonium salt.
Yes.
So how you know that it's ammonium salt? By observation. By seeing. Smelling. Ammonium salt cannot be smelled, okay? Because no smell in it. Iron will have no smell. Good try, okay? You just search something on the web. How about the others? Now there are two possible methods. I can think of two possible methods. Method one. Now, for example, if I finally get the sample of sodium, I narrow down it is a sodium carbonate or sodium hydrogen carbonate. I would like to do further tests. I want to get to know which is which, right? So I try to put this as a scenario. You may first of all, what you're going to do is to, in case they are just solid, what you're going to do is to make it as a solution, okay, by adding distilled water. And then I add what? I add one chemical, calcium nitrate. Why? Why? We've got two cases. In case I have got white PPT, I know what is the original chemical. In case there is no PPT, I know that that is another case. Do you know? If it is white PPT, I know it is carbonate. If no PPT, it's hydrogen carbonate. Why? This is what you know.
Is that because there is a displacement reaction happen and the calcium carbonate doesn't dissolve in water, and the calcium hydrogen carbonate will dissolve in water?
Yes, very good. Excellent. So you may find that. Why is it like that? Because the white PPT is because of the water insoluble calcium carbonates form. No PPT is formed is because of what? Calcium hydrogen carbonate. It is also water soluble. So you will never have a chance of having a PPT. Can you get my point? So this is one way. Is for the further test to further know which is carbonate or hydrogen carbonate. And second case, the second method that you may think of is by what? Is by heating. It's by heating. It's by heating. Why? For the sodium carbonate, I heat it for long, there will be no observable change because there is no reaction. But for sodium hydrogen carbonate, while you heat it, what would be formed? Do you know? Search on the web now. I heat sodium hydrogen carbonate. I heat it. What would be formed? Of course, I refer solid. Sodium.
Sodium carbonate, water, and carbon dioxide.
Yes, that's right. So you are going to either test it with lime water again, to test the gas form with lime water again, or test the presence of water vapor by what paper?
I saw on the internet they said you have to measure the weight loss.
Sorry, measure the weight loss. You can. But if you are going, you think of the method, it is a method. Okay, it's a method. But if you ask for a chemical test, your method is not a test. It's not a chemical test.
Okay.
Can you get my point of the wording? It's very difficult. Yeah, but you need to be highly aware of this. Of course, what you say is correct, because once I heat it for long, these two will go away. Of course, the mass will drop. Okay, the mass will drop. The whole mass will drop because the original chemical, it contains hydrogen and carbon and also oxygen, right? They will leave away as carbon dioxide and water. Of course, it's lighter. Okay, but if you use this to help, remember you are going to use this. For example, you have got CO2, H2O, you are going to test the water vapor. If you want to get to know this carbon dioxide, you are going to test with lime water, for example. It's fair enough, okay? Which means that if you there will be more chances, right, for more different combinations for you to get to know which chemical it is, isn't it? Why do I say so? Because if you want to go back to our cations, altogether we have got this KCA. I might like this way. I try to step back to the chemical metal reactivity series. Aluminium, zinc, iron, lead, copper, silver, and also ammonium ion. Now we have got a list of the cation in which it will give you certain chemical tests, right? And of course, if you test certain identity of cation, it will be rather problematic. For example, these four is easy because I use flame test, it will help. But if you want to talk about magnesium, aluminium, zinc, lead, it is problematic because I add an alkali. Only by using the alkali, it will give you a white PPT. But different, if I use NaOH or if I use ammonia, the white PPT will then form, and this will some of them will dissolve in excess alkaline, some of them will not. I do two tests. Only by having two tests, would you know that it must be which chemical? Is that clear? And these field is rather easy to do because, for example, this iron 2 and iron 3 is easy because before you do anything, if you take a look at the solution is color. Based on the color, I will know something more about that. Okay, and what's next is I add alkali. It doesn't matter whether or not it's a little amount or in excess. Okay, both will form iron 2 hydroxide, iron 3 hydroxide. It's in form of a color PPT. So based on the color, I will directly know which is which. Do you understand? Okay, how about silver? Silver is also possible because I add alkali to it. For example, hydroxide. It will form a gray PPT, which will not be dissolved in excess. Alkali. But I add ammonia, the gray PPT will first form, but later on we would be dissolved in excess. Ammonia. So I use this and it will help. How about ammonium compound? Is it easy? It's also easy. Why? If I add NaOH to it, what will happen? Do they have any PPT? No. There will be no PPT, but I warm it. What will happen? They will form ammonia. So what you need to do is to test for the presence of gas, ammonia, alkaline gas, by using what? Moist blue litmus paper. And I turn it to red. And I do it in another way around. A red litmus paper, I turn it blue. And it's the only alkaline gas that you know. A pungent smell that come out, right? So we have got a list of cations. We will help you get to know which is which. Do you understand? How about anion? So far, you know chloride, bromide, iodide, flame test, right? Silver nitrate test. Do you still remember? We got a look of different color PPT. White, creamy yellow, yellow. How about carbonate? How about hydrogen carbonate? Okay, we need to do two tests. First of all, I add dilute acid. Check for the colorless gas bubbles to be formed, being verified is carbon dioxide first of all, and then you do the further test. Is that clear? So which means that we have got different combinations, right? We have got so many cation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 cations, and cation we have got 5 choices. So of course I will give you a list of different combination of cation anion. We have got different chemical, and you'll be asked about the chemical identity of this. Is that clear? Questions? Do you get afraid of it? Of course, yes, because what is the hidden message? Your hidden message you should prepare a note card with you, which lists all those chemical tests, starting from chapter 1 and so far. And you are going to further add, because you don't the later on you know more about other chemical tests for other ion. Okay, in the coming 2 years. Do you understand what I've just said? Understand? 明啊？即係要整個 notes 咯喎。羅列晒 try to list all those cations and what is the test, what is the observation, and try to list all those anions, what is the chemical test, what is the observation. And you leave the space and listen to the teacher saying, and you try to start to add them more underneath. Only by doing so, you can start to know how to study chemistry. I tell you the truth, right? How about a class practice 14.6 A part? How would you distinguish which is which? That's right. One. To the solid, I add what?
Hydrochloric acid.
Dilute hydrochloric acid to each solid respectively. Observation, please. We have got 2 cases, right? The one which gives what?
carbon dioxide.
Carbon dioxide. So how will you say it in as an observation? Observation.
Gas bubbles is evolved.
Yep. So what is that? What's the two chemical? The first one is sodium carbonate. The other one is sodium nitrate. Do you understand? So the test itself is just one test, a chemical test, right? But you already give you a difference in the observation, and I would know which is which. Can we use flame test? Flame test. Can we use flame test? No. No. Why not? It will give the same flame color, which is golden yellow, right? So that test is not a good test for you to distinguish which is which. And how about B?
Flame test.
Flame test. Somebody say flame test. Flame test. So what is the observation? Perform flame test. So two observations. Bright red flame. I know it's calcium ion. But how about the others? No characteristic flame color. Okay, no characteristic flame color, which is zinc chloride. But some of you may say so, Mr. Chu, you can distinguish. But wait a minute, you see the word chemical test. Now my question is flame test a chemical test? Is it a chemical test?
I don't think it's a chemical test.
It's not a chemical test actually. So if you just suggest a test, if you say a test, this method one is okay. But you say that a chemical test, this method is not okay because flame test is not a chemical test. So what does mean by chemical test? Chemical test is the test in which I add chemical to it and they would perform its own chemical property by giving you a chemical reactions. If I use this concept, chemical reactions, and you may know, for example, you take a look on this. Why you have got color gas bubble is because there is a reaction between the acid and carbonate, the hydrogen, ion, and carbonate to form CO2 and H2O, but not for nitrate. So that's why you use this as we call it as a chemical test, because afterwards you can write down a chemical equation. How about this? If you think that method one is not a chemical test, then you think of method two. Yes, you are forced to think of an alkali, right? So you are going to add what alkali? NaOH or ammonia? NaOH or ammonia?
Ammonia.
Ammonia. If I use ammonia, what will happen?
Both give white PBT with a few drop of NH3. And
A few drops.
exists NH3, the lab will
will not dissolve.
Mm-hmm.
However, the sample that contains zinc ion will the white PBT will be dissolved to give a colorless solution.
Mm-hmm. Mm-hmm. Correct. Agree? Do you agree? Calcium ion react with ammonia to form PBT. Calcium ion, ammonia, will they form PBT? The answer is no PBT. Why? The concentration of hydroxide ion in a dilute ammonia solution is too low. Okay, so even though there is trace amount of hydroxide, it's not enough to precipitate the calcium hydroxide out as a solid. So you can still say it as no PBT. So it is but not for NaOH. Okay, if I add a few drops of dilute ammonia into each of the solution respectively, there will be two cases. One, no PBT. No PBT, you already know it is calcium chloride. The other case is white PBT. I know it is the sample being zinc chloride is because of why zinc hydroxide, which is a water insoluble substances, is formed. Do you understand? Now, okay, what Zhang Deliang has suggested, all those sentences, you change the chemical a bit, and while the whole answer will become correct. Please change the chemical. Which chemical should be changed? From ammonia, I cross them out, I change it to what?
Sodium hydroxide.
Yep. So I add sodium hydroxide solution. Separately, so a little NaOH added, two cases, right? And then what will happen? So you mark it here. If I add a little amount of sodium hydroxide added, so both will form white PBT. Both will form white PBT. But this time it's not enough. I would like to add excess NaOH to both cases. We've got two cases. White PBT remains, and white PBT dissolves. Okay, for the second case, for the third case is calcium hydroxide. I know. For the original chemical, it is what? Calcium chloride. The other case is a zinc chloride. Okay, is the reason white PBT. White PBT, it is zinc hydroxide dissolves to form what? To form zincate, which is in form of a complex, colorless complex. So that's why I would have this third method. Is that clear? I've got the third method now. You understand? So by doing so, I do hope you get to know more about qualitative analysis. Questions? Do you find qualitative analysis funny, interesting, right? But you may find it a little bit confusing as well because it's rather informative because we have got quite lots of data to memorize. But it seems like what for some careers relating to chemistry, we usually use this type of thinking. For example, being a doctor, okay, a vet, nurse, you being a lab technicians, etc. Right? So in which you may need to get lots of information, you put it inside your mind. What you need to do is to rearrange the chemical test into different order with your own concept to memorize it, and be prepared to ask anytime that you need to pick up those information and then ask and then try to apply. So this is what how chemists try to gather the things together. It seems like the Chinese medicine doctor, right? You go there and you visit them, and they will give you some pills, right? Some drugs. No matter it's Western or Eastern, you will do the same thing, right? After doing so, you come up with something in your mind, and you go to the shelf and get the chemicals that you want to give it back, give it to you, and ask you to take. So it is what we will call that as a chemist we usually do. It's fair enough, right? So today, what I've just mentioned to you is about the chemical test. It brings to you a world of a qualitative analysis. Remember, qualitative analysis, it deals with the identification of chemical species present in a known sample. So because of that unknown samples, so the focus of the chemical test must be, you have to choose the chemical test which is unique. Unique. U-N-I-Q-U-E. The case, what is meant by unique is that that test can already narrow down all the other possibility and to give you that must be the chemical. We call that unique. Of course, not all chemical tests is said to be unique. For example, I add dilute acid to it and you give effervescence. I turn lime water milky, just like this. But you can still do this, okay? Because it helps you narrow down the all other different possibility into two. What you need to do is to think of another test for you to help to get to know which is which. We will call it as, it's not identifying, we call it distinguishing. So you may heard of one more term, identifying and distinguish. Now that two term is different. Identify, which means I really know what it is. Distinguish is I know the difference. Do you understand? Okay. 辨認分別 or 辨別. Okay, so the meaning behind is a little bit different. If you use distinguish, if you use the word distinguish, just like this one, take a look on that example. Sorry. If you use the word distinguish, it is very simple. It's because what you need to do is odd one out. You focus on calcium ion and zinc ion and tell me the difference, and it's okay. Okay, you take a look on sodium carbonate, sodium nitrate. I take a look on carbonate and nitrate. It tell me the difference, and it is okay. But if you ask about the same questions on the term identify, you need also to tell me that, for example, B part, you need to give me one more test to show that the anion is correct before you tell it is identification. So that's why to take a look on example of B part, if you're asked to think of the identity of calcium chloride, you need to do two tests. One is flame test. The other one is silver nitrate test. Only by doing so, I will know which is that the chemical itself is calcium chloride. If you just do one of them, I just know only part of the compound. Do you understand? very challenging, isn't it? Right? Very challenging. Okay, next week I start to have a quiz with you on acid and alkali. Get yourself prepared about that. I know that you need to have a talk. I can notify. I need to release to all of you. Now, before you leave, can you tell me what is the difficult part to you today? You need to have a talk, right? Is it? I find some of you who haven't finished your MCs. Hey, don't hide away. I tell you. Somebody who failed to do the MCs, it's time to do. Practice makes perfect. Do not procrastinate your work. Otherwise, you'll find that you soon know that you have quite a lot of to memorize. Okay. It's time to say goodbye. Bye-bye.
Bye.
Bye.